Recursion is a programming concept where a function calls itself. Now, this can get pretty dangerous because a function that calls itself is then going to call itself again and again and again and again and again, and it's going to keep on repeating. So a good recursive function has a method in it that will stop that at some point. This is often referred to as a test value. So this test value will be used to determine if we're going to call that function another time. So here's an example where I'm passing in a counter to a function called message. And if my counter is greater than 0, then I'm going to print out a statement and call the message again. In that print statement, I'm going to let us know where the counter is. Now, in message 2, you're going to see something that's going to be very, very similar, except I change the order when we call message 2 versus our print statement. And when I run these two, I'm calling them both from a main function. When I run these two, you're going to get very different results with how they're printed. And this makes sense because in one case I'm printing, then I'm calling a message. I'm printing, and I'm calling a message again. And the other time I call a message before I get to a print. And that means I call the message again when I call it a second time. And so it just handles the order differently. This is part of what makes recursive functions very, very powerful, but a little confusing as well if you're not used to them. So let's take a look at an example of this function that calls itself. And then we'll look at message 2, which also calls itself. So the first example is where we're calling message. And because we print out message and then call message second time, you'll notice we see we're on call 5, 4, 3, 2, 1, and 0. But with message 2, our print statement comes after we call message 2 a second time and a third time. And so the numbers are now in reverse order from 1, 2, 3, 4, and 5. So this is the basics of recursion. The idea where we're going to call a function and that function is going to potentially call itself again as long as the condition's met. Now, if the condition is not met, we will get an error. It's called a stack overflow error. And this is just an error where it can no longer handle deeper and deeper recursive calls. So this is something that's pretty standard. Everyone, when they start writing recursive functions, makes this error. And then we go, oh yeah, that's right, we need a test. And we have to go in and test for it. Now, both of these functions are called direct recursive functions. And that is, the function directly calls itself. There is also something referred to as indirect recursive calls. An indirect recursive call is where function A calls function B, and then function B calls function A, which calls function B, and there might be other functions mixed in there. That can become a little bit more troublesome to troubleshoot, so we always have to be really careful of that, but it is more common to have this direct recursion. Now you might look at this and go, well, isn't this kind of similar to a loop? And the answer is yes, it is. Most things that can be done with a loop can be done with recursion, and vice versa. There are a few things where this is not the case, and in those cases, usually it is something that can be done recursively that cannot be done as a loop. Now, if something can be done as a loop, generally we should do it as a loop, because loops generally are faster than recursion calls. Also, you're much less likely to run into a stack overflow call or an out-of-memory error with a loop compared to a recursive call. So, if we can use a loop, we generally should, but it is helpful to know about recursions when it's possible. In our next video, we'll take a look at some recursive examples and how those are used in Python as well as other languages.